So far we were dealing with the visual ray method. Now vanishing point method. Question number 6. Rectangular prism of dimension 80 by 48 by 32 mm is lying on the ground plane in such a way that one of the largest faces is on the ground. A vertical edge is 10 mm behind picture plane and longer face containing that edge makes 30-degree inclination with the picture plane. The station point is 80 mm in front of PP, 60 mm above GP, and lies in a center plane which passes through the center of the prism. Draw the perspective view of the view by vanishing point method. So earlier we had seen the visual ray method. Here it is vanishing point method. So half part of the portion is similar to the visual ray method, but some slight difference is there. So first we have to draw the top view of the solid in the given position. The larger face is on the ground means its dimension is 48 by 80 by 48 by 32. So this is 80, this is 48. That's the larger face. That is, it is lying on that larger face with the longest edge, with a vertical edge 10 mm behind picture plane. So this is 3 edges. This is bottom 2.2, top 0.3. This 3 edge is vertical and it's 10 mm behind. This distance it is 10 mm behind picture plane. So this is the picture plane. This line is the picture plane. This is the picture plane. Now it's make an angle. The longer edge is making an angle 30 degree. Now all corner points, this one, and this one, and this one, all these points are joined with the SP. SP is at what distance? It is 80 mm in front, and the center plane passes through the center of the prism. So this is 80 mm. So from this end to this end it is 40. From there you have to draw here. So this is the station point, picture plane. From there 80 mm. So this is the station point. Now all these 8 corner points have been joined to a station point. So this is coming here, this is coming here, this is coming here, and this is coming here. Now one more thing we have to do. This up to this part it is very similar to the visual ray method. The another thing is that we have to find the vanishing point. So for that, draw a line from SP towards picture plane in such a way that this line is parallel to this edge. So if you draw a line parallel to this edge from SP to picture plane, that will be the vanishing point, right? So this point where this line meets the picture plane is called vanishing point, right? Similarly, to this edge you can draw a parallel line from SP to the picture plane, so that this point is called vanishing point left, vanishing point left, VPL. Now we have to come to the horizon ground line. This is the ground line. Now you need not draw the front view. Instead you can draw the horizon line. Horizon line is, and this horizon line is 60 mm above ground line. So this is 60 mm. So you draw a horizon line HL. Now from VPL dash you draw a line to the horizon line. So this is called VPL dash. Similarly, from the VPR you draw a line, so that you will get a point called VPR dash. Now the thing is that this vertical edge does not touch the picture plane. So if it had touched the picture plane, in perspective view it would have appeared as the true length, that is 32 mm. That vertical edge length 23 is having a height of 32 mm, that is given in the question. So what we have to do is that we have to produce this line to meet the picture plane. This point is not VPL is this one. Both are very close. You have to be very careful. When this edge is taken to picture plane, this point is called this point is to be noted, and from that line you have to draw a line to the ground line so that it will meet the ground line here. You take a point here which is at a height of 32 mm. Which is at a height of 32 mm. Because if that edge had, if 2-3 edge had touched the picture plane, it would have a length of 32 mm in the perspective view. Now from this end and this end you draw two lines to the vanishing point right dash, VPR dash. From here you draw two lines. On that line will lie 2 and 3. So how 2 and 3 will be obtained? You have to come to the top view. So this is the point 2, 3, that is joined to the SP. So that will pierce this point, this picture plane at this point. So from there you have to draw downward so that you will get 2 and 3. Now again on the same face is lying BC. On the same, this is 2, 3, this is BC. So that is BC. Now so here it is meeting. So from there this may be B1, this may be C1. Drop downward so that you are getting this point B, this point C. So 2, 3 BC face is obtained on two lines drawn to VPR dash. Now AD is, if you look at the top view, this point is AD. So from BC towards left is AD. So because of that reason we have to draw from B and C you join to VPL dash. B has to be joined to VPL dash, C has to be joined to VPL dash. On that line will be lie AD. So AD how will you obtain? This is the point AD. Drawn that point to SP. So here will be A1 and D1. From that point you draw downward. So that will meet the line through B at A, line drawn through C at D. So A and D is obtained. Now we want to get point 1 and 4. So now listen. If this is 2, 3, this is 1 and 4. This is 1 at the bottom, 4 at the top. Now that is joined to SP. So here it is 1, 1 and 4, 1. So from that point you draw downward, and from this 3 you have to draw a line to VPL dash. From 2 you have to draw a line to VPL dash. On that line will lie 1 and 4. So from 1 and 4 you have drawn downward. So the bottom point is 1, top point is 4. So now you join. So again to this face also, the top face also, so it can be drawn. Only this 1A line has to be dotted, AD line has to be dotted, AB line has to be dotted. So this is the solution using vanishing point method.